We have this function ft of period 2 pi on the interval 0 to 2 pi, ft equal to t squared. So the graph looks like this on 0 to pi. On the other interval, you just copy that. Now let us compute the Fourier series of f. Ft a0 over 2 an cosine nt bn sine nt n from 1 to infinity. A0 is 1 over pi because we work with the function of period 2 pi, and we have from 0 to 2 pi. So integral from 0 to 2 pi ft dt. So this is a0 an 1 over pi 0 to 2 pi ft cosine nt dt. Bn 1 over pi 0 to 2 pi ft sine nt dt. Let's compute it. So the first one, one over pi 0 to pi t squared dt. So 1 over pi, we have t cubed over 3, 0 to 2 pi. 1 over 3 pi, so 8 pi cubed minus 0. 8 over 3 pi squared. So this is our A0. An 1 over pi 0 to 2 pi t squared cosine nt dt. Here you do the integration by part to compute that, and in this case you need to do it multiple times, so I write the di table. And derivative and integral. And remember, integration by part, there's one method you could usually do, not always but usually, like it. So we have logarithm invertebrate algebraic, which in this case we choose u to be t squared. So you have, here's the d columns and here's I column, derivative and integral. You do for t square here for u equal to t square, and dv equal to cosine nt dt. With that you do the di table. So now let's start do that. 2t cosine, so we have sine nt over n, 2 minus cosine nt n squared, 0, sine nt minus sine nt n cubed. You multiply this one and this one. The integral we have here, which is an, t squared times this minus 2t times this and minus 2 times this. T squared sine nt, so plus t squared sine nt divided by n minus 2t minus cosine nt over n squared and plus 2 minus sine nt over n cubed. And then we remember to put a limit there. 1 over pi t from 0 to 2 pi. 1 over pi 4 pi squared sine n times 2 pi over n. 2 minus minus, so I will plus 2 times 2 pi cosine 2 pi times n over n squared minus 2 over n cubed sine n 2 pi. Then we minus 0, 0, 0. With these terms, when t equals 0, this one also 0. 1 over pi 4 pi squared, but sine of 2 pi times n 0. This term 0, this term 0, so we non-zero term here. Cosine of 2 pi times n, this one is 1. So you have 4 pi times 1 over n squared. 4 over n squared. This is our an. Similarly, you can compute bn. Bn minus 4 pi over n. And those the Fourier series is ft a0 over 2 a0, so we have over 2, it is 4 pi squared over 3 plus summation n from 1 to infinity an is 4 over n squared cosine nt, and we get bn minus 4 pi over n sine nt. This is a Fourier series of f. Now we need to compute, we need to deduce these two equalities. So remember that we already write here. This is Fourier series, this one equal to f of t at the point of continuity, and at the point of discontinuity we have this one Fourier series converges to the half the average of the limit, left hand limits and right hand limits. So let's see, we want 1 over n squared, 1 over n squared. So we want these terms. We want something over n squared. So I want to choose t such that the Fourier series, this term something over n disappear. I can choose at the point t equals 0. Let's call this Fourier series, call it f t. And I consider Fourier series at t equals 0. So this one equal to 4 pi square over 3 plus summation n from 1 to infinity 4 over n square cosine n times 0, the cosine 0, minus 4 pi n sine 0. So these terms will be 0. This one is 1. So we have Fourier series, this one. F Fourier series at 0 equal to this one. Now we don't want 4 over sum 4 over n square. We took this 1 over n square. So we have, let's do this first, 4 over n square here, the summation equal to the Fourier series at 0 minus 4 pi square over 3. Now we divided that by 4. Summation 1 over n square, n from 1 to infinity 1 over 4 Fourier series at 0 pi square over 3. That's 4 cancel out with this. So now all we need to do is compute Fourier series at 0. So this is our function ft. The graph looks like this. You see that 0 is a point of discontinuity. F is discontinuous at 0. The limit ft t tends to 0 minus, so t tends to 0 from the left. The function ft is this is 2 pi square, which is 4 pi square. The limit ft t tends to 0 minus is 4 pi square. The limit ft t tends to 0 plus, t tends to 0 plus is tend to 0. 0 square, which is 0. So now we know that a Fourier series f at 0 converges to the average of the two limits. Limit f t tends to 0 minus limit f t tends to 0 plus over 2 4 pi square plus 0 over 2 pi square. So that's f0. Now this formula here becomes one over 4. F0 is 2 pi square minus pi square over 3. So pi square over 2 minus pi square over 3 pi square over 6. So that explains why this one equal to pi square over 6. That's what they ask us to do here. And similarly, you can compute this one. So to show this one, so they want us minus 1 n plus 1 over n squared. So they still want to consider this term. You just want to make it so that this sign is alternating. So you can choose similar before, do it for f at pi. Yeah, you can do it for f at pi. You can deduce the second equality.